Okay, in this video, we are going to model the distributive property by using algebra tiles. But before we actually get to the distributive property, let's talk about how to model algebraic expressions using algebra tiles. So what are algebra tiles? There are actually tiles that are yellow and red to represent the different parts of an expression. The X tiles are rectangular in shape. They can be horizontal or they could be vertical, either one. The yellow, if you have the actual tiles, represents positive x's, or the positive variable, and the red would represent negatives. Now, even though we call them X tiles, they actually represent whatever variable your expression has. Then you have the unit tiles. The unit tiles represent your constants, like 3, 4, -7. Okay, unit tiles are squares, and they are represented, yellow is positive, red is negative. Now, you're going to be drawing drawing the algebra tiles, and when you're drawing them, you definitely need to put a positive or a negative for the unit tiles. For the X tiles, you should also label them with a positive or negative. A lot of times, you'll see models and the positive will have an X instead of a plus sign, or it might not have anything at all, and that is going to represent a positive. Okay. For the negative, it would definitely say have a negative symbol on it, or like a negative X. Okay, so you definitely have to represent negative with that negative sign on there. Okay, so let's go ahead and do some. You should be doing this in your journal. We're going to first model x plus 3. So x is our variable. We need an X tile. How many do we need? Well, the invisible number that's in front of the X is a 1, because if you have an X, that means that you have one, at least one. So we're going to need one X tile, and it's positive. Then we need 3 unit tiles. Just like we did with integers, you need to look at the sign that goes in front or to the left of your constant. In this case, it's a positive. That means we need 3 positive unit tiles. So this would be the model for x plus 3. If we're going to model t minus 2, even though our variable is a t, we're still going to represent it with our X tile. It is positive. Then if you look at your 2, it's not a positive 2. The sign in front of it tells us that it's a negative 2. So we're going to need to have 2 negative unit tiles. So this would be the model of t minus 2. Okay, let's talk about multiplication, 3 p's. That's exactly what it says. You need 3 p tiles, so 3 X tiles. 1, they're positive, 2, and 3. If you had 7y, you would need 7 y's or 7 X tiles. Now let's talk about division. M divided by 4. So m is your variable, so you need an X tile. It is positive, and we want to divide it by 4. So what do you think that means to do? Well, hopefully you're saying to yourself, oh, just cut it into 4 equal pieces. So all you're going to do is just split the tile into 4 parts. Then on the expression z divided by 3, you're going to do the same thing. Here's your X tile for z. There's only one of them. And you would cut it into 3 equal parts. Okay, go ahead and get out your worksheet that says Distributing with Algebra Tiles. As we go through these examples, you need to follow along and make sure that you're doing all of the modeling and writing of the expressions that I do. If you need to pause the video to stay caught up, please do so. Okay, we're going to start. There are different ways to represent expressions, or algebraic expressions. One way is to represent them in words. 3 groups of 2 X tiles and 1 unit tile. Another way is to model using the algebra tiles. Then you can actually write the algebraic expression. And if you'll recall, multiplication is really repeated addition. So we can take that expression and we can simplify it by using repeated addition. So let's go ahead and get started. 3 groups of 2 X tiles and 1 unit tile. So in the group you have 2 X tiles, so you're going to need to make a group and put 2 X tiles in there. and 1 unit tile. It does not say 1 negative unit tile, so it is a positive. So this is one group. And it says we need 3 groups, so you're going to actually duplicate that group 2 more times so that you have a total of 3 groups. And here we go. 3 groups, each group has 2 X tiles, each group has 1 unit tile. Now we can go and write this as an algebraic expression. If you'll remember when we talked about order of operations and we talked about parentheses, I said parentheses is a type of grouping symbol. So we're going to be using the parentheses here to represent groups. In our group, we want 2 X tiles and 1 unit tile. So parentheses, 2 X's, and it is a positive unit tile. So the group is actually 2X plus 1. And then on the outside of the group, to the left, you're going to write the number that you want. How many groups are you wanting? In our example, we want 3 groups. So this would be how you would write the algebraic expression. 3 groups of 2X plus 1. To show you repeated addition, because 3 groups means to multiply by 3, instead we're going to show this as repeated addition. We're going to take our 2X plus 1, our group, and we're going to add it 3 times. There we go. 2X plus 1 plus 2X plus 1 plus 2X plus 1. So we're going to start and add up our constants. They're all positives. 1 plus 1 plus 1 is going to be a positive 3. And then add up your x's. 2 x's plus 2 more x's make 4 x's. Add another 2x and you have 6 x's in total. So our simplified expression would be 6x plus 3. So we took our algebraic expression of 3 groups of 2x plus 1 and we got rid of the grouping symbols. We said, hey, we don't want any more groups. We want to actually have a simplified expression. And we got 6x plus 3. So let's try another one. Number 2, 2 groups of 1 X tile and 5 unit tiles. So here's the 1 X tile. The 5 units are positive because it does not say that it is negative. So we're going to draw our 5 unit squares with the positive symbols. And how many of these groups do we want? We want 2 of them. So we're going to duplicate it and we have our 2 groups. Now let's write our algebraic expression. It's going to be 2 groups. So 2, the number of groups, goes to the outside of our actual group. Parentheses, and in each group we have 1 X tile and 5 positive unit tiles. So that is your algebraic expression, 2 times the group of X plus 5. Repeated addition means that we take the group X plus 5 and we're going to add it together 2 times because we want 2 of the groups. When you add it together, what is your constant going to be? A positive 10, because 5 plus 5 is 10. And how many x's? 1x plus 1x is going to give you 2 x's. I can't stress enough that when you have just the variable by itself with no coefficient, that there really is the invisible coefficient of 1, that this is really 1x plus 1x, and that gives you your 2 x's. So what I'd like for you to do is to go ahead and do number 3 and number 4 on your own. Pause the video. Once you've completed all of your modeling and writing of the expressions and simplifying them, then come back and check to see how you did. Okay, let's see how you did. 3 groups of 3 X tiles and 3 unit tiles. So you can clearly see that I have 3 groups. Each group has 3 X tiles and 3 unit tiles. The algebraic expression, 3 groups, so 3 times the group of 3x plus 3. Repeated addition, I add 3x plus 3 together 3 times. 3 plus 3 plus 3 is going to be a positive 9 because they're positive 3's. 3x's plus 3x's make 6x's, plus 3 more make 9x's. So we went from the expression of 3 times the group of 3x plus 3 and simplified it down to 9x plus 9. And you can check yourself, come back over here to your model. Do you have 9 x's? Add up all of your x's. Yes, there are 9. Do you have 9 positive unit tiles? Add up all your positive unit tiles. Yes, there are 9. So you did it correctly. Now look at number 4. Number 4 was a little different because instead of being 2 positive unit tiles, there were 2 negative unit tiles. So this is what your model should look like with the algebra tiles, 2 groups. Each group has 4 x tiles, and each group has 2 negative unit tiles. The algebraic expression is 2 times the group of 4x minus 2. We do our repeated addition. We're adding 4x minus 2 plus 4x minus 2. So these are both negative 2's. So a negative plus a negative is going to be a negative 4. And 4x's plus 4x's give you 8x's. So now that we can go from the expression and we can simplify it using repeated addition, let's see if we can take out the repeated addition step. I want you to see if you can find the pattern from going from this algebraic expression that includes the grouping down to our simplified expression. Okay, this is called using the distributive property. We're doing something to the algebraic expression and simplifying it down to this x minus 4. So go back and look at all 4 examples and see if you can come up with a pattern. Pause the video. When you think you have the pattern, come back and check. Okay, let's go back and start with example 1. How can we turn this 2x into 6x's? Well, what did we do in our repeated addition? We added it together 3 times, right? And repeated addition is multiplication, so really we could take our 3 and multiply it by our 2x to make the 6x's. And then we could do the same thing and multiply it by our 1 unit to make the 3 positive units. Okay, let's see if it works over here. If I want 2 groups, that means I want 2 x's, 2x, and then 2 of the 5's. 2 times 5 is 10. 3 times 3x makes 9x's, and then I want 3 groups of this positive 3, so 3 times 3 is positive 9. Does it work when you have negative units? Well, I want 2 groups of the 4x, so 2 times the 4x's gives us 8x's, and 2 times the negative 2, positive times the negative, will give us the negative 4. Okay, so that's our pattern, and this is what we call our distributive property. So in your journal, go ahead and pull out or open up to your properties of operations sheet. We've already talked about the commutative, associative, and identity property, and let's fill out the distributive property. The distributive property says you can multiply a number by a sum or multiply by each number in the sum and then add them together. So numerical example, if you have the group of 4 plus 8, you can multiply the 3 by each term or each number inside the parentheses. So 3 times 4 plus 3 times 8. Algebraically, you can do it with the letters A times B plus A times C. So go ahead and finish filling out your properties of operation notes page, and then you'll be ready to watch the second video.